we're solving problem 4 from the 2020 F equals MA exam A. 4 identical rods, each of mass m and length 2d, are joined together to form a square. The square is then spun around its center, as shown in the figure, at an angular frequency of omega. What is the magnitude of the force that the joints between the rods and the corners of the square must bear? So we have this rough drawing where the distance from the center to an edge, 90 degrees, if it's 90 degrees to the edge, is exactly d, because we know that it's half. So then we have these forces going inwards, and this force will make an angle theta to an edge of the square. Now applying a formula, or applying just finding how much of force it has to bear the top rods, we can say that 2 times the force times the angle sine of theta will be equivalent. This here will be equivalent to mass times the angular frequency squared times d, the distance. So from this, we know that angle theta is pi over 4 degrees. So then we plug that in, or radians. So sine of pi over 4 is root 2 over 2. So 2f root 2 over 2 is m omega squared times d. That 2's cancel out, and you simply find that force is mass times omega squared d over root 2. So this is how much force it has to bear at the corners for the rods.